Hi, my name is Anjali and welcome back. Today we'll solve the question linked list cycle part 2. So basically you're given the head of a linked list and you need to return the node where the cycle begin. If there is no cycle, you need to return none. For example, here the linked list is 320 minus 4. Minus 4 is pointing back again to node 2. So you can see the start of the cycle is at the node 2. So you need to return the node 2. The function should return the node where the cycle starts, which is node 2 over here. I hope the question is clear. Let's move on. So before moving forward in this question, you should know how to detect cycle in linked list. And if you don't know or if you have any confusion over here, so you can find the video on detecting the cycle in linked list in the description below. Now let's move on to important steps. So we know that in Floyd's tortoise and hare algorithm, if there is a cycle in the list, the two pointers tortoise and hare will eventually coincide, confirming the existence of cycle. This we have already studied when we were detecting cycle in a linked list. So our first target is to check if cycle exists or does not exist. Why? Because if cycle does not exist, we can return null and our question ends over here. But if a cycle does exist, then our objective is to identify the starting point of the loop. So we have cracked half of the question where we will first detect if there is a cycle. If there is no cycle, then we can return null. Now let's understand from the example. So let the linked list be 1, 2, 3, 4, 5, 6, 7, 8 and 9. 9 is pointing back to 6. So let's first observe the point where slow and fast pointer coincide. So you know initially slow and fast pointer are pointing towards the head node and slow is moving one step at a time whereas fast is moving two steps at a time. So in the first iteration, slow will jump to node 2 whereas fast will jump to node 3. Similarly, in the second iteration, the location of slow pointer will be at the node 3 whereas fast will point at the node 5. So going on, it will jump from 4, it will jump to 7, 5, 9, 6, 7, 7, 9, 8, 7 and 9 and 9. If you have confusion over here, try to make this table by yourself. So what it is happening, it is going to 7, from 7 it is jumping to 9, again it will jump to 7 because 9 dot next is 6 dot next is 7. So we have to jump to 9 dot next which is 7. So you see at the 8th iteration they both coincide, slow and fast pointer coincide over here, which proves that it has a cycle and it is the node where both coincide. So what we have got over here, we have got a node where both slow and fast pointer coincide, which is node 9. So till now we have a reference of a node where both slow and fast pointer coincide. But our target is to return node 6, which is the starting point of the node. Let's move on. So based on the above table, we can prove that the pointers meet at the node 9. The slow and fast pointer meet at the node 9 at the 8th iteration. Now, we aim to determine the starting node of the loop, which is node 6. To conduct an experiment, let's assume our head is positioned at the starting node. Why? We already have a reference of the starting node, which is 1. So let's say head is referring to the starting node, which is 1. Very easy, right? And then we identify the point where both pointers meet, which is 9 we have just seen, which is no 9 in the above case. Afterwards we advance both pointers one step at a time and observe where they coincide. Now let's create a table to illustrate this experiment. So we have our linked list 1, 2, 3, 4, 5, 6, 7, 8 and 9. 9 is pointing back to 6. We have two pointers, our head pointer which is initially pointing at the start of the node, which is node 1, whereas we have another pointer coincide point, let's say coincide point, which is pointing at the node 9. We have just seen that, and both are advancing one step at a time. Let's see what happened in the iteration. So in the first iteration, head will jump from 1 to 2, whereas 9 will jump from 9 to 6. That is what is written, 2 and 6. In the second iteration, it will jump to 3, it will jump to 7. Therefore, 3 and 7. In the third iteration, it will jump to 4, whereas it will jump from 7 to 8. So 4 and 8. In the fourth iteration, it will jump to 5 and it will jump to 9, right? So now head is pointing at the node 5, this, and coincide point is pointing again at the node 9. In the fifth iteration, head will jump to sixth node and the coincide point will also jump from 9 to 6 as you see here, and we got our result. So what we can say, so to identify, so what we can conclude over here, to identify the starting point of the cycle, which is 6, which we wanted, one pointer should be positioned at the start of the list and the other position should be at the position where the slow and fast pointer initially met node 9. In the above example, we have seen that advance both the pointer one step at a time, and the point where they coincide after advancement indicates the beginning of the cycle. Therefore, we achieved our purpose by using two positions. One is at the head node and the other at the coincide point. So now let's move on to the pseudocode over here. So pseudocode would be fairly simple for us. First, we need to find out whether cycle exists or does not exist. And if cycle do exist, we need to find out the coincide point. So that is covered in this part of the code. And this part of code we have already seen when our target is to detect the cycle in the linked list. If there is a cycle, it will return the coinciding point, else it will return null. I hope this portion of the code is clear to you because we have discussed about this in detail when we were detecting the cycle in the linked list. Now let's move. So till this point, we know that whether cycle do exist or does not exist. So if there is no cycle, meaning coincide point will be equals to null, we can simply return the null and that is the end. If the cycle do exist, what we need to do? We have two pointers now, head which is at the start of the node, coincide point where slow and fast pointer met. So what we'll do, we'll advance one step at a time for both till they coincide again. So head will become head dot next, coincide point will become coincide point dot next, and then you can return head or coincide point, doesn't matter because they become eventually equal. Now it's time for LeetCode. This is problem number 142, linked list cycle part 2. So we are given the head of a linked list and we need to return the node where the cycle begins. If there is no cycle, we need to return none. Let's start writing our code. What we need, first we need to find out the coinciding point. Let's say coincide point equals to find cycle and we'll pass in the head, right? This we have seen in our pseudocode and also in the steps. So I've already written the code for finding out the cycle. This is fairly simple. We have two pointers, slow and fast. This is a condition. If there is a coinciding point, it will return that. Otherwise, it will return null. Okay, moving on. If there is no cycle, meaning if coincide point equals to null, what we need to do? We need to return null. Else, what we need to do while our head is not equals to coincide point, we will keep on iterating. So head is equals to head dot next, and let me just copy this. Otherwise, coincide point equals to coincide point dot next, and we can return null over here. Sorry, head over here. Let's try to run the program. Okay, so you see here all the test cases, 3 test cases are accepted over here. It's time to submit. There you go. So you see all the test cases are accepted successfully and you beat 100% of users with Java.
I hope you have enjoyed this video very much. Notes are available in the description below. Please do like, share and subscribe. We'll meet in another video. Till then, bye bye. Take care.